Hello friends. So far we are discussing the complex number chapter. So far we have seen the definition of a complex number, which is nothing but z is equal to your x plus iy, where the real part of a complex number z, which is nothing but your x, and imaginary part of a complex number, which is nothing but your y. Okay, not iy. Then we have seen a complex conjugate of a complex number, which is nothing but x minus iy. Only we have to change the sign from I to minus iy. Then we have seen the modulus of a complex number, or absolute value of a complex number, which is nothing but x square plus your under root of y square. Okay, under root of x square, which is always real and positive. Then we have seen the Argand diagram. Suppose you have given any complex number and you want to represent graphically the given complex number. This is your real axis, this is your imaginary axis, and you want to represent any one complex number. That is called as your Argand diagram. Then we have seen the several forms of a complex number, which is nothing but your rectangular form of a complex number, which has coordinate x and y. Then we have seen a polar form of a complex number, which has coordinate r and theta, that is r cos of theta plus I times sine of theta. Okay. Then this is your exponential form of a complex number, z is equal to r e raised to your I theta. This is your exponential form of complex number. Then we have seen the algebra of a complex number. Okay, algebra of a complex number. So in that case, we have seen the addition of a two complex number, z1 plus z2, as well as the subtraction of a complex number. Then we have seen the multiplication of a complex number and division of a complex number. We have seen the mathematics approach as well as your Argand diagram. In all the case, this is represent a complex number. The resultant is represent what? Complex number. Then last lecture we have seen the power of a complex number. So you want to find out the nth power of a complex number, which is nothing but z raised to n is equal to r raised to n e raised to I n theta. Okay, so this is your power. Suppose you want to find out the nth root of a complex number, then this is r raised to 1 by n. Then we can write this is cos of theta plus 2 pi k divided by n plus I times sine of this is theta plus 2 pi k divided by n. Okay, so where your k is your positive integer and which is running from 0, 1, 2 up to n minus 1. And lastly, we have seen the logarithmic of a complex number, which is nothing but ln of z, which is nothing but ln of your r plus I times theta. Please remember, in real case, we will only find out the logarithmic of your positive integer, but in complex number, we can find out the logarithmic of your negative numbers. Okay, so here you will get the value of ln of minus 1. Okay, so this is overall we have seen till date. Okay, now today we will see a trigonometric function. Okay, so suppose, so this is trigonometric function. Suppose you are given any function which is nothing but, suppose this is e raised to x. So here you have to find out the infinite series, just like 1 plus x square upon 2 factorial and so on. So that is the tedious case. But suppose you have given any function, this is just like e raised to z, and z is your complex number. So instead of finding out the infinite series problem, here you will get a quick solution. Simple. Suppose here is you have e raised to 2 minus pi I. Okay, So how I will get that one? So 2 minus pi is your complex number. So we can write this is e raised to 2, okay, and e raised to minus pi r. So I will get what? E raised to 2 into e raised to minus pi is what? This is your cos of pi minus sin pi. Sin pi is your 0 and cos pi is your minus 1. So you will get the answer is minus e raised to square. So within a 2-step you will get an answer. But if you are doing using infinite series, then this is the tedious case. Okay. So that thing we have to do here. So we know there is a close linkage between whom? This is a complex exponential and the trigonometric function. Okay, trigonometric functions for a real value or real angle. Okay, so what is the relationship? That you can find out using Euler formula. E raised to I theta is equal to cos theta plus I times sin theta. So this is a close relationship between a complex exponential and your trigonometric function, that is your cos and sin, okay, for any real angle. Okay, so this is the case. Now here you have to find out, suppose theta is replaced with minus theta. Okay, so this will be e raised to minus theta I theta, which is nothing but cos of minus theta plus I times sin of minus theta. Now this is your even function, this is your odd function. So what we can write? Cos of minus theta is nothing but what? Cos of theta, and sin of minus theta is your minus. So minus I times sin of theta e raised to I theta. So this is my equation 1, this is my equation 2. Now I want to find out the cos theta term. Okay, so using equation, so I will add up equation 1 plus equation 2. What you will get? This is e raised to I theta plus e raised to minus I theta is equal to, this is cos theta. Suppose I will write cos theta plus I times sin theta plus cos theta minus I times sin theta. This term is get cancelled, so you will get 2 times of cos of theta. So what you will get the value of cos theta? So cos theta is nothing but e raised to I theta plus e raised to minus I theta upon 2. Okay. So similarly, suppose we will do for subtraction of 1 minus 2. Because I want to find out what? I want to find out the value of sin theta. So this is nothing but e raised to I theta minus e raised to minus I theta. So in that case, the cos plus this term minus and here is plus. So cos get cancelled. So you will get the term is 2I sin of theta. So what is the value of sin theta? Sin theta is nothing but e raised to I theta minus e raised to minus I theta divided by 2I. Okay, so here you will get, this is suppose third and this is your fourth equation. Okay, so you can find out the real angle value using the addition of your exponential, means the complex exponential. Okay, so still we are finding out what? We are doing all the calculation for real angle theta. Okay, and the given method is simple. Okay, to integrate, means integrate of the exponential is simple as compared to the cosine term. Means suppose you want to do the product, just like your sine of theta into cos cube theta, and you want to find out the integral of this d theta and everything. So instead of that, the product of the exponential, and you want to find out the integrate of such function. So in that case, so exponential functions are easier as compared to your sine and cosine function. Now we want to see the physical significance in physics point of view. Okay, so here we have to remember what? Here the term is cos of theta is equal to e raised to I theta plus e raised to minus I theta upon 2. Okay. Now interesting, suppose I am to find out graph of e raised to x. So it is just like this one. Okay. Exponential means it is going just like this way. Okay. E raised to minus x. So it is going just like this way. Now when you are replacing x with your I theta, we are replacing the x with your I theta, then in that case x is rotating, means the complex exponential function is rotate in a complex plane. So this is your real axis of a complex number, this is an imaginary axis of a complex number. So if you are given e raised to I theta, then the complex function is rotate in a complex plane. Okay, so suppose any wave is oscillate in this particular case. So simple, we will take an example. Suppose this theta is replaced with omega t. Okay, so where omega is what? Omega is my frequency, and as the t goes on increasing, t suppose increases, it means that this will be okay. So this is your e raised to something I omega t will be here as the t goes on increasing. So this is rotate in counterclockwise direction. Okay, so this is e raised to I omega t is describe what? This is describe a circular motion. Okay, it is described in a circular motion but in a counterclockwise direction with frequencies omega. Okay, now second is what? You want to define, this is e raised to minus I omega t, because I want to find out the value of cos omega t. So we have replaced this theta with omega t. So this is cos of omega t, which is e raised to I omega t plus e raised to minus. So this is minus. So your t, so that will be here somewhere. Okay, so this is your, it has direction. So simply again this is e raised to minus I omega t is describe a circular motion. Describe a circular motion with clockwise, with a clockwise, with frequency is your omega. Now we have to do what? E raised to I theta plus e raised to minus I theta. So we have to do the addition of this one. So what we will do? We will draw a parallelogram here. Okay, so this is my e raised to I omega t. So we can draw one parallelogram here having the magnitude is what? E raised to I omega t. Same size I will take here. So this is e raised to minus I omega t, and using the vector addition of this one. Okay, so this is just like, suppose my complex number z1, this is your z2, and z1 plus z2, you will get a resultant like things. But this is represent what? This is represent your real axis. Okay, so real axis means the oscillations are taken place along the real axis. Means when you are talking about, this is cos of, just like cos of omega t, which is e raised to I omega t plus e raised to minus I omega t divided by 2. So in that case, the oscillation is took place where? Along the real axis, because e raised to minus I omega t is the complex conjugate of this particular number, so it is coming here. Okay, and when you will do the addition of e raised to I omega t and e raised to minus I omega t, so that oscillation is always took place along your real axis. Okay, so that will be the case. What about sine omega t? So this is nothing but what? Sine of omega t, which is nothing but e raised to, this is I omega t minus e raised to minus this one divided by twice of I. Okay, so in that case, please remember the things. Okay, this is my e raised to I omega t. So where will be e raised to? So that will be here, suppose e raised to minus I omega t. But we have required minus e raised to minus I omega t. So that will become here. Magnitude is same, only direction is opposite. So that will be minus e raised to minus I omega t. Okay, then we can find out the parallelogram of this one. So it will be here. Okay, and the resultant will becomes along the imaginary part of a complex number. Okay, so cos of sine of omega t, so that is nothing but what? The oscillation is took place along your imaginary axis. Okay, so in cos case, the result oscillation is took place along your real axis. In case of your sine of omega t, the oscillation is took place along your this one. Okay, so this is the physical significance in case of your physics part. Okay, so simple thing we have taken, theta is replaced with omega t, and that oscillation is took place. So this is represent actually real term. This is represent what? Your imaginary term. So obviously the oscillation is took place along your imaginary part. This is took place along your real part. Okay. Now till we are focusing only the real things. Okay. So your angle is real. But instead of, suppose the theta angle is replaced with your z. Okay, means this is your cos theta is equal to e raised to I theta plus e raised to minus I theta upon 2, and this is sin theta is equal to e raised to I theta minus e raised to minus I theta upon 2I. Now you have changed theta to z, means you want to find out the cos of z, means instead of that theta number you have to change with complex number z, and that is nothing but cos z, which is equal to e raised to z. Okay, means ij plus e raised to minus ij divided by 2. In case of the sine of z, which is nothing but e raised to ij minus e raised to minus ij divided by twice of I. Okay, so in this case we'll see one problem. So in case of the trigonometric function in complex number z, so that is nothing but only theta is replaced with your z. Okay, now my theta is means changes with function, and that is your complex variable. Now suppose I am to find out cos of I. I is nothing but z. So here my z is what? Z is equal to I. Okay, so instead of z we can put I. So this is I. Z value is I plus e raised to minus I. This is also I divided by 2. So this is nothing but what? E raised to I square. I square is minus 1 plus e raised to, this is I square is minus 1 minus minus plus. So here is 1 divided by 2. Okay. So suppose we will simplify this one. So this is simple, 1 divided by twice e plus e divided by 2. So that value become 1.543. Okay, and suppose you can take a value of sine. Suppose problem, this is pi by 2 plus I times ln of 2. This number you have taken. So in that case you will get the answer is pi by 4. Now see, if your angle is real, theta is suppose real, so in that case your value is nothing but what? Sin theta, modulus of the sin theta, or that one which is always less than or equal to 1. Cos theta, which is nothing but less than or equal to 1. Means simple, suppose you have taken sine of 0 is 1. So this is my complex plane. Okay, so this is 1. That time sine 0 is 0. Cos pi by 2 is 0. Sine pi by 2 is 1. So you will get maximum 1 here. Cos pi is minus 1. That will be here. Sine 270. So that time I will get a minus 1. So this is just like a unit circle. And their sign means value is not more than 1. But in these two problem, if your variable is complex variable, then that case you will get the value is anything. Anything means which is greater than 1. In this case this is not possible, greater than 1. This is less than or equal to 1. But if your variable is complex variable, okay, complex cos of this z value, cos of sine of z value, so in both the cases you will get the value is greater than 1, or you will get anything. Okay, so that is possible using your complex variable. Okay, so this is the case you have to see here. So next is your this one, hyperbolic function. Okay, so we have seen this is your cos of z, which is nothing but e raised to iz plus e raised to minus iz divided by 2, and this is sine of z, which is nothing but e raised to iz minus e raised to minus ij upon 2i. Now suppose we will take the given complex number z is equal to iy. This is your purely imaginary number. z. So x is equal to 0. Real part we have considered 0. So z is equal to your iy. So what we will get? This is cos of iy, which is nothing but this is e raised to I, and this is your iy, plus e raised to minus, and this is your iy, divided by 2. So this become e raised to I square y plus e raised to minus your I square y divided by 2. So this become I square is equal to minus 1. So this is e raised to minus y plus I square is equal to minus minus plus. So e raised to y divided by 2. So we can write this is e raised to y plus e raised to minus y divided by 2. Okay. What happened in case of the sign? So this is cos of iy. Okay. So in case of the sign, z is replaced with iy, which is nothing but e raised to, this is I, this is your iy minus your minus into this is y divided by 2 times I. So e raised to y, I square is minus 1. So this is minus, I square is minus minus plus. So e raised to plus iy divided by 2i. So we will divide and multiply with I. So what we will get? Here is I. Okay. And here this is e raised to minus y minus e raised to y divided by 2i square. Now this I square is replaced with minus 1. So here you will get what? Minus. Here will be plus. So that value I times this is e raised to, I will write positive term first, then e raised to minus y divided by 2. Okay. So this is your sine of y. Now this term is indicate what? Okay. So this is a real number. E raised to, no complex term is present here. E raised to y plus e raised to minus y divided by 2. So you will get here is real number. Here is also real number. Okay. So on the right hand side, okay, on the right hand side you will get the real function on the right hand side of this particular function, and which is abbreviated as hyperbolic sine. Okay, this part you already learned in mathematics. So this is hyperbolic sine. So that is nothing but, or hyperbolic cosine. So this term suppose I am to write, then we can write this is cos of, means hyperbolic cosine of z, which is nothing but e raised to z plus e raised to minus z divided by 2. Same thing, the hyperbolic sine, which is denoted by this number, which is nothing but e raised to z minus e raised to minus z divided by. Okay, so this is your cos of hyperbolic z, okay, or hyperbolic cosine is equal to this one. So this is real, this is your real function, and that is linkage with this one. So where is the useful of your hyperbolic function? So when you have to find out any curve, nature of the path. Okay, suppose I have to design one bridge. here. Okay, so what will be the curve path of that particular bridge, and this calculation you can do using a hyperbolic function, and in that case this is very useful case. Okay, so in today's lecture we have seen what only these terms we have seen. This is your cos of z, okay, which is nothing but e raised to z plus e raised to minus I z divided by 2. This is sine of z, which is nothing but e raised to I z minus e raised to minus I z upon 2i. Then we have seen this is a hyperbolic cosine of z, which is nothing but e raised to z plus e raised to minus z upon 2. Then we have seen a hyperbolic sine of z, which is nothing but e raised to z minus e raised to minus z upon 2. Okay, so this is the case.